Hello everyone. Ray optics and optical instruments part 2. Refraction and total internal reflection. Refraction. Refraction mainly is a phenomenon involving the bending of light at interfaces which separate two mediums of varying optical density. So we can consider an interface of air and water. The main cause of refraction is because of the change in speed of light in the two media. Now let us consider a obliquely incident ray of light. Part of it gets transmitted into the second media, which is water, while the rest of it gets reflected back into the same media, which is air. Now air is considered to be optically rarer than water. So in case of water, which is much optically denser than air, the speed of light decreases and hence the light bends towards the normal. Here I is the angle of incidence at the interface and R is the angle of refraction. Now the bending of a ray of light at the interface of two medium is called refraction of light. Now Snell was able to experimentally obtain two laws for refraction. First one states that the incident ray, the refracted ray, and the normal to the interface at the point of incidence all lie in the same plane. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant, which is the second statement, which means sine of I by sine of R is equal to a constant, which is n21, which is the refractive index of the medium 2 with respect to medium 1. Now, based on the optical density of the two medium involved in the phenomenon of refraction, we can see whether the refracted ray moves towards the normal or away from the normal. That is, if n21 is greater than 1, the refract angle is lesser than the incident angle. That is, the refracted ray bends towards the north. In this case, medium 2 is optically denser than medium 1, and hence light travels slower in medium 2. If n21 is lesser than 1, then the refracted angle is greater than the incident angle, and the refracted ray bends away from the normal. This is the case when the light goes from an optically denser medium to rarer medium. That is, if light goes from water to air. Now, if N21 is the refractive index of medium 2 with respect to medium 1 and N12 the refractive index of medium 1 with respect to medium 2, then N12 is equal to the reciprocal of N21, or we can say that N12 into N21 is equal to unity. It also follows that if N32 is the refractive index of a medium 3 with respect to medium 2, then N32 is equal to the product of N31 into N12, where N31 is the refractive index of medium 3 with respect to medium 1. Now we can see some consequences of refraction. First one is the lateral shift, which is observed when we look at pins placed on one side of a glass slab. In the case of a glass slab, there are two interfaces. One is the air glass interface and the other is the glass air interface. The first interface, that is the air glass interface, the ray of light passes from a rarer medium to a denser medium. Hence the ray of light bends towards the normal. While in the second interface, the ray of light passes from a denser medium to a rarer medium. Hence the refracted angle R2 is greater than the incident angle I2, and this results in the lateral shift. The two refractions happening at the two interfaces of the glass slab. Now second is the apparent depth, that is the real depth is h1, but the apparent depth is only h2. This happens in the case of a tank filled with water due to the refraction of rays of light passing from water to air. Since the rays pass from a denser medium to a rarer medium, they bend away from the normal, and hence the bottom of the tank appears to be raised. Now, third one is due to refraction happening in the Earth's atmosphere. Due to the refraction of sunlight by the Earth's atmosphere, the sun is visible even before it actually rises, that is, it reaches the horizon, and it stays even after the sun has set. There is a delay of 2 minutes. Now we can see total internal reflection. In the case of total internal reflection, we have to consider that a ray of light passes from a denser medium to a rarer medium. And this phenomenon happens when the angle of incidence at the interface is greater than a critical angle. Critical angle is the angle at which the refracted ray just grazes through the interface. That is, the refracted angle is 90 degrees. If the angle of incidence is greater than critical angle, all of light rays get reflected into the first medium itself, and none gets transmitted to the rarer medium. Total internal reflection occurs when a ray of light travels from a denser medium to a rarer medium, and the angle of incidence at the interface is greater than the critical angle. Now, the angle of incidence corresponding to an angle of refraction 90 degree is called the critical angle of the medium. So, by using Snell's law, which states that sin I by sin r is a constant, which is the refractive index of medium 2 with respect to 1, n to 1 at critical angle, that is IC, r is 90 degree. So we get sin IC is equal to n to 1. Now we can see the total internal reflection in nature and its applications. First one is the phenomenon of total internal reflection which we observe in nature, which is mirage. This we can observe in deserts where the air is very hot during afternoons. During afternoons, the air just above the surface of the ground gets heated and they become lighter, while the cooler air above this is much denser. So when light comes from a tree, it passes from a denser air to a rarer medium, which is the hot air below it. When the incident ray is much higher than the critical angle of the air interface, it undergoes total internal reflection as shown in the figure B, and hence the light appears to be coming from somewhere under the ground itself, and hence the sand appears to be like water. Now diamond. In diamond, total internal reflection is used to get the brilliance of the diamond. Diamond has got a very low critical angle. That is, the diamond air interface has got a critical angle of only 24.4 degree. So by cutting the diamond in such a manner that the light entering the diamond is able to undergo multiple total internal reflections inside it, the diamond can be made brilliant. Now prism. Prisms can be used to invert images of objects without magnification of the objects. The object can be inverted by using 90-degree as well as 180-degree. Two configurations as shown in the figure A, which is the 90-degree configuration, and B, which shows the 180-degree configuration of the prism. Now optical fibers. Optical fibers serve to transmit light signals through it by using the property of total internal reflection. Optical fiber consists of a central core having a high refractive index and an outer cladding having a lower refractive index. And the light signal entering the optical fiber is such that its angle of incidence is much higher than the critical angle, and hence it undergoes total internal reflection. And the consequent total internal reflections result in transmitting the light signal through the optical fiber. Since optical fiber transmit the signal by using total internal reflection, the transmission loss is greatly reduced, and it is even possible to transmit light signals through bent optical fibers. So this is the end of this video. In this video, I have discussed the phenomenon of refraction and total internal reflection. If you have got any doubt, please comment in the section below. Thank you.